Ladies and gentlemen, welcome to my video presentation of the virtual poster with the title Digital and Low-Cost Development of a Polarimeter on a Raspberry Pi. My name is Manuel Wehner from the Friedrich Schiller University, Jena. In this video presentation, I will present you my 4 sections of my poster, beginning with a small introduction, the development of the digital polarimeter, the measurement and comparison to an analog polarimeter, and the outlook of this project. A big challenge for STEM lessons is the digital data acquisition. It is also an important topic for modern STEM education, but most of the devices used are focused on scientific research, which makes the use difficult for pupils. Many of these devices are expensive too, so there is often only one device available for teachers only. That's the reason why there are a lot of low-cost measurement devices built with focus on education. These devices are easy to use, but the evaluation is still often done by hand. To allow use of a digital device, I built a polarimeter based on a Raspberry Pi. For this, the angle of rotation is measured similar to a photometer by light intensity sensor for determine the transmission of a LED as a light source. 2 polarization filters serve as a polarizer and an analyzer. To be able to determine a rotation angle, the analyzer was glued to a servo motor. For the framework of the polarimeter, Lego bricks are used. These serve to stabilize the servo motor, but also as socket for the LED. A large transparent plastic jar for peppermint candy is used as a cuvette. To control the sensors of the polarimeter, I used the free software LabPi I programmed earlier. This software was first adapted and tuned to the functionality of the digital polarimeter and now displays the measured values in a tabular and graphical form. The curve progression and measurement data can be compared directly or exported for further analysis. By moving the servo motor, a complete sine curve can be mapped. The extremes of this curve represent the measure point for determining the change of the angle of rotation. Depending on the concentration and the layer thickness, the phase of the sine curve is shifted. The differences between the extremes allows to determine the rotation of the polarized light. To calibrate the digital polarimeter, the 0 point of the angle of rotation was determined with distilled water. To show the precision of the digital polarimeter, the specific rotation angle of sucrose was determined with a concentration series and compared with measured values of an analog polarimeter. The software LabPi and the polarimeter are still in development. While the software is available as freeware, the polarimeter is still in process of optimization and further customization. On this point, I hope I draw your interest on my poster and thank you very much for listening to my video presentation.